Wear on the cylinder inside wall can be determined from the compression pressure measured before disassembly. Normally, the cylinder inside wall tends to wear more in the upper portion, especially in the piston thrust direction. If a piston ring is broken and seized, or if the engine overheats, the cylinder inside wall can be damaged or seize up. It is necessary to check the cylinder bore wall for wear and damage. Using a cylinder gauge, measure the cylinder inside diameter in the upper, middle, and lower portions, each in 2 directions, for a total of 6 positions. Subtract the minimum measurement from the maximum. If the difference is greater than 0.2 millimeters, bore the cylinder. If the engine overheats, or if the crankshaft does not rotate, each piston must be checked for damage and deformation. First, using a micrometer, measure the piston outside diameter. With the piston upside down, measure the piston diameter in the thrust direction, 38.5 millimeters from the piston's bottom edge. Subtract this measurement from the minimum cylinder bore diameter measured in the thrust direction. If the difference exceeds the permissible range of 0.06 to 0.08 millimeters, replace the piston or the cylinder block. If oil consumption is high due to oil loss via the piston ring, or if compression pressure is low, check each piston ring for damage, wear, or seizure. The clearance between each piston ring and ring groove must also be measured. Insert a thickness gauge into the ring groove through the gap between the ring and the groove wall and measure the clearance along the entire circumference. Also, measure the piston ring end gap with a thickness gauge. For measurement in the cylinder bore portion with the least wear, use a piston to push the piston ring into the cylinder bore to an 87 millimeter depth from the cylinder block's top surface. Now the crankshaft will be inspected. First, inspect the crank journals and pins for damage and seizure. Then, using V-blocks and a dial gauge, measure the circle runout of the crankshaft. The circle runout can be determined from the deflection of the dial gauge as the crankshaft is rotated once. The maximum permissible runout is 0.06 millimeters. Using a micrometer, measure the crankshaft diameter at these journal and pin positions. Calculate out of roundness and taper. At both journal and pin positions, the maximum permissible out of roundness and taper values are 0.02 millimeters. If there is conspicuous streaking or seizure on the crankshaft, or if circle runout or uneven wear exceeds the specified limit, replace the crankshaft. You have studied the major inspection methods of disassembled parts. Various other inspections may be required depending on the problem. Master proper inspection methods with reference to the repair manuals.